Physics Part 135. This is also unsatisfactory. It takes a lot of time to label all the boxes, which is much better to draw the circuit diagram using a set of symbols recognized by everyone, which do not need to be labeled. Well, the figure shows the symbols that you are likely to need in school and college work, and which you will meet in the examination questions. You will have met many of them already. It is important that you learn these so that you can recognize them straight away. The only labels you are likely to see on them will be the values of the components, for example 1.5 volt for a cell, or 22 omega for a resistor. Series and parallel circuits, Kirchhoff's first law. A series circuit is one in which the components are connected one after another, forming one complete loop. You have probably connected an ammeter at different points in a series circuit to show that it reads the same current at each point. A parallel circuit is one where the current can take alternating routes in different loops. In a parallel circuit, the current divides at junction, but the current entering the junction is the same as the current leaving it. The fact that the current does not get used up at a junction is because current is the rate of flow of charge, and the charges cannot accumulate or get used at a junction. The consequences of this conservation of electric charge is known as Kirchhoff's first law. This law is usually stated as the sum of the current entering junction in a circuit is always equal to the sum of the currents leaving it. At the junction, it's shown in the figure. We've got an example for you. For the circuit of figure, state the readings of the ammeter A1, A2 or A3. A1 would read 175 meter ampere, as the current entering the power supply must be the same as the current leaving it. A2 would read 75 minus 25 is equal to 50 meter ampere, as the total current entering the junction is the same as the total current leaving it. A3 would read 175 minus 75 is equal to 100 meter ampere. It's your turn. Number 1. The lamps in the figure are identical. There is a current of 0.0 ampere through the battery. What is the current in each lamp? Number 2, the figure shows one junction in the circuit. Calculate the ammeter reading. Electromotive force and potential difference. When charge passes through a power supply, such as a battery, it gains electrical energy. The power supply is said to have an electromotive force, or EMF for short. The electromotive force measured in volts the electrical energy gained by each coulomb of charge that passes through the power supply. Note that in spite of its name, the EMF is not a force. The energy gained by the charge comes from the chemical energy of the battery. EMF is equal to energy converted from other forms to the electrical divided by charge. When charge passes through a resistor, its electrical energy is converted to heat energy in the resistor. The resistor has a potential difference VD across it. The potential difference measures in volts and the electrical energy lost by each coulomb of charge that passes through it. PD is equal to energy converted from the electrical to other forms divided by charge.